Hello guys, and welcome to CAM 2019. I'm so glad all of you guys are here. A lot of familiar faces in the audience. I know what you're all thinking. Who in the right mind would give me a microphone to ramble at you for about a half an hour, like I'm doing already? Guys, I'm here to talk to you about profitability with adaptation, innovation, and data science. What I want you guys to all walk away from here is a good understanding of where more advanced analytics and AI solutions are currently being performed in my world, in the pricing and underwriting realm, and also outside of just the pricing and underwriting, where we're seeing machine learning and more kind of clever algorithms being provided across the insurance industry as a whole. For those of you who don't know, my name is Alan O'Loughlin, and I lead the Statistical Modeling and Analytics team, specializing in pricing and underwriting for the EU, and off we go. Okay, guys, I love talking about this slide. I find any excuse to use in any presentation I give. You can tell here if these guys make a wrong step or if something goes wrong and they don't adapt quickly, it'll end disastrously for them. So I think it's quite relevant for this when I'm talking about adaptation. One kind of key word as well within that is adaptability, and also don't be fooled by buzzwords. You'll hear a lot of buzzwords being used in analytics about kind of needing to invest in AI and machine learning and stuff like that, but unless you're actually being smart about the end-to-end solution, you might end up with something that's very shiny at the front end and does some nice analytic stuff, but the right amount of investment hasn't been put in the back end of your ingestion phase of the data to allow you to actually do like more complex, cooler stuff. This slide is now is a survey that was taken at a recent analytics and AI event that I was presenting at. I was kind of surprised to see a lot of people pick phases that are sort of traps within this space in terms of ranking the importance of these phrases when it comes to AI and analytics. And I'm surprised to see like data ops and DevOps so low, because if the right amount of investment isn't put into this area, then you actually won't be able to do any of the sort of more cooler stuff that's associated with analytics and AI. I'm kind of here to talk to you guys about the spectrum of analytics. We've got 6 petabytes of data within LexisNexis as a whole. The IQ Hub for the UK did over 1 billion transactions in January alone. And how you're sort of capturing that data that sort of comes in and out of your 4 walls is very important about moving forward and understanding customer trends, being able to do more advanced analytics on it. It's no use in just having that data, hosted on a server in the back of somebody's closet, because you have to structure it correctly, put proper indexing on that data, so then when you're able to query it, you're not waiting 2 weeks for the answer to come back and computer says no is your response. On the linking side, the linking is incredibly important. How you reconcile an individual, and one of our key strengths is the Lex ID. How we reconcile an individual to be able to pull all of their records from our different data sets before we do our roll-ups, our calculations. It's incredibly important. And a lot of our analytics, it's a keystone of our analytics, and we couldn't do it without it. All of this stuff actually has to happen before we even get to the modeling side, before we have all that raw data returned on the individual, the car, the vehicle, the address, the postcode. All of that information is returned to us, and then we can do our roll-ups to calculate our attributes, build our scores, all with customer-focused solutions in mind. I'm sure a lot of you are familiar with customer segmentation modeling. But if not, I'm going to give you guys a bit of a crash course, whether you want to or not. Imagine that you have an idea of a perfect color in your mind. So you want to paint your house a specific shade of green that you have just in your mind. We know from back in the 1980s, you wouldn't have been able to do that. Dulux's back catalogue wouldn't have had the range of colors it has today. As time has sort of moved on, we know that there's over 1 million different colors that are distinguishable between the human eye, and there's very few number of shades out there that you actually can't get. Being able to pick the most perfect shade of green is about being able to differentiate it from one to the other. I think this uses as a metaphor, as a great metaphor for actually when it comes to pricing insurance risk. So back in the 1980s, the things that people used to rate on might have just been a case of the value of the car, or actually an individual knowing a broker or underwriter. Then when it involves, you introduce more rating factors like, occupation, the area. Then we started introducing credit information in the early noughties. Where we are today is just the amount of data that we can actually throw and test and have links and relationships to an actual individual's risks is sort of limitless. We're in the space of, we're looking at telematics data, quote intelligence data, policy, behavior. All of that information is really good at differentiating risk. If you guys look at the chart on the right-hand side, what you're actually seeing here is this is actually a really good model. You're seeing the red line is your predictions, and the bins then are your actuals. Now, this in itself is actually a good model, but what you'll see within the gaps is that this is model leakage. Model leakage means you're kind of short something. When you're building your model, you're finding that, hey, I'm pricing, let's say, two 40-year-old doctors, both driving a Ford Fiesta or a similar car, but I'm finding my predictions are not equal to my actuals. How do you greater differentiate that 40-year-old doctor? When you start introducing telematics data, we see there are things like, hard braking, braking speed limits. All of that can be used in further differentiating pricing. We know kind of recent county court judgments, ID&V verification. Now, I don't know if everybody knows a couple of fake doctors. I'm sure they exist, but also address stability as well. We see all these being new differentiators of risks, all in all trying to close that gap on the model leakage and give you better pricing for your underwriting and more accurate. Just to bring you guys on a sort of a journey of the process we kind of go through when we're modeling with customers, introducing new data. What chart you're sort of looking at now is an insurer's performance. The red line represents their ability to accurately predict risk from low to high, split into equal bins of exposure. And then we put some blue lines in there as well to make sure that any benefit we're counting is outside the realm of statistical noise. So you'll see that this model is actually doing quite well. It's predicting it's low risk good and it's high risk good as well. But when we add new data on top of that, we'll see greater differentiation in its ability to actually predict low risk and high risk, meaning that you can give your best customers a cheaper price and price for your highest risks a bit more, or potentially not right for them at all. There's a lot of nice graphs within these presentations, but one of the most important points here is in one sentence: rebuild and refresh. Before you go out to the market and start investing in new data, what I would do is I would look internally to see if your own data can explain some of the risk or the patterns you're seeing in the market. Refreshing your models gives you that sort of insight before you go out and invest in new data sources. And when you are investing in new data sources, the thing I would say is that not everybody knows, but order is important. So the order in which you bring in new data and test current data is very important. One data set might have more coverage than the other while they're highly correlated. You need to be able to measure metrics like, hey, is this additive above and beyond? And then take that out again, and then take something that's correlated out and put the new stuff in. So again, order is important. You need to have certain metrics that show each new data set offers something above and beyond, or if they're equivalent, you need to make sure stuff like coverage is important as well. Once you kind of decide on your best credit model, then you start investing in new data sources, like adding in new attributes like policy insights. Some of the policy insights attributes could be kind of correlated with some of your current rating factors, but we've seen in the market that the policy insights attributes are exceeding expectations of some of the most sophisticated insurers and underwriters out there. So we know that this data is offering greater differentiation above and beyond current rating factors that are in the market. Insofar as when I talk about innovation in this space within my team, we have so many products now like policy insights, risk insights, quote intelligence, is that if we throw all of this over the fence at any insurer, that's something close to maybe over 700 attributes that they would have to kind of work through. Now, where we find innovation is using more advanced machine learning techniques in order to tailor fit that wide range of attributes to a customer-specific portfolio of business. Being able to reduce the amount of attributes that are being used, you're sort of narrowing the playing field. And then once the playing field is narrowed, we often find traditional GLMs to be incredibly powerful and predictive. On top of that as well, I haven't found a really cool way yet of using neural nets in the pricing and underwriting space, but I'd be very interested to see what the future holds for that. Another key point is the methodologies you use to select attributes is only as good as the data you have. You have to make sure you've got the right data, otherwise any testing will be completely invalid. There's a certain mindset out there in the market now that AI, machine learning will replace the underwriter, and that's just not the case. There is no black box solution that just straightforward replaces the human interaction. The amount of things from an analytics perspective that we find that are predictive, that are so kind of counterintuitive that we couldn't actually deploy into a model is actually quite funny. I was having this conversation with a friend recently where they said, when I was telling him this story about finding things that you'd never expect to be predictive, actually being predictive, he said, I knew it. It's all tea leaves and chicken bones that you throw up in the air, which I thought was quite funny. We can use more and more techniques to put some greater insight on top of the data. Again, once you've narrowed that playing field and you've introduced more advanced techniques to narrow what you're looking at, you then need what we would say the human intervention, and what I'm referring to is sort of palatable rating factors. You can find certain factors that are actually quite predictive, like let's say you had somebody constantly shopping for the cheapest possible price of insurance without properly understanding the excess or the terms of the policy. We actually know that this sort of behavior is a bad risk, but you can't create a rating factor that would adversely punish these bad risks if you have the UK government, which is actively promoting people to go out in the market and shop because premiums are actually increasing. So you very much need that sort of human intervention, because the black box won't tell you that. And then before you start feeding those rating factors into scoring your risk. I spent a lot of time talking about the innovation, the machine learning algorithms that we're using inside of the pricing and underwriting world. I wanted to, guys, give you a bit more of a glimpse of the sort of stuff that we're using outside of the pricing and underwriting world. We see now in the telematics space that when somebody has what we say maybe as a black event might be doing twice the speed limit within an urban area, the insurer has the right then to cancel that policy. Now, how you record the actual speed limits on routes is through, image recognition. And then before we actually cancel somebody's policy or policy is cancelled, we need to be very certain that that was the actual speed limit in the area. So you still need that manual intervention. So while there's some clever stuff going on and, it cuts down a lot of man hours, the manual intervention bit is still very important. What we see as well in the world is that we see the driverless car. The driverless car is on its way, so we know that there's lots of information being collected now from the OEMs or the connected car. We know that there's lots of differences in how certain OEMs are referring to certain safety features, and being able to take all of that different information that's being recorded by the cars, being able to normalize that data, so we're comparing apples to apples and oranges to oranges, because things we've seen in the market already is that one safety feature in one make and model of a car compared to the same safety feature in another make and model of the car is actually completely different. And we're seeing that now, that people who are using combinations of, LiDAR and cameras are far more successful in lowering loss, frequency of claims and collision of claims compared to safety features that are just one or the other. Other things that we're seeing now in the market where image recognition is being used, it's about improving the customer journey. So as soon as an accident or a collision has occurred, the customer can take a picture of the damage, upload that to their insurer. The insurer benefits because of the early notification of loss, and the customer journey is improved because hopefully the payout of the claim is processed a lot faster. Now, this industry could potentially be ripe with fraud without some sort of trust score that moves in parallel before the claim itself is actually paid out. Other things that we kind of see in the market now is around chatbots. Personally, I don't find chatbots overly helpful. I feel kind of confident enough when I'm going through navigating a website where I can usually find something. There might be a bit of arrogance on my side that I'm kind of comfortable, that I think that I'm comfortable navigating most websites and finding where the issues is. So when it comes to me needing help on a website, I haven't traditionally found chatbots overly useful. Now, what I have found is there's lots of other open source chatbots where you can actually test how good or how powerful they actually are. So to answer the question, are the robots taking over? The answer is no. They've already taken over. I'm just kidding. Change is the only constant. So going back to the beginning, profitability through adaptation, you got to be aware of what's going on around you, and the more advanced analytics and AI solutions that are being deployed for the industry. But I wouldn't say go out there and just ad hocly invest in what might be complex front-end systems. You very need to make sure that your whole infrastructure is set up correctly to allow you to track the incoming data right through to the final pretty output, or where some of the smart stuff is kind of going on. So guys, I'd like to thank you very much for your time, and I really appreciate you coming and watching the talk. Thank you.